Is it uneven?
Okay.
No.
Yeah, it's really white. It's so dark. Is it flipped? Or am I
Probably the camera.
Is anybody on the live right now?
I'm on level. I'm just not doing that for myself.
Okay.
Yeah, I can hear you.
There's audio. Why'd you mute it? Just in case. Why'd you
Oh,
mute it?
yeah.
Okay.
Should
It's good.
we make like a general area like where we like should?
So, welcome to the summer internship at Clemson College closing ceremony. They're going to talk to us about what they've learned and done for the last 8 weeks. I'm Brian Melton, and I'm here on behalf of Professor Sledge. She's watching this online, so hopefully you can hear her. And I'm going to welcome you all to this closing ceremony so that we can learn what the interns do for the summer. We're able to do this because we have a National Science Foundation grant with the Stokes Alliance for Minority Participation, which is baccalaureate. And the goal of that grant is to get students to transfer to university to get a bachelor's degree in STEM field. I think everybody here is doing that. In our program, Dr. Williamson is the PI for the program, and we partner with HCC, Houston Community College. Co-PIs are Sharon Sledge, and she's the co-PI and program director. And we have Jeff Steer, ACC. And I'm Brian Melton. I am the program assistant. So all the paperwork, all the fun stuff I try to get done. And then we have an external evaluator who is Dr. Amanda Hapler. And I believe she is online watching this as well. And she gets feedback from all of you, and researches everything that we do to see what works, what doesn't work, what do we need to change, how can we make it better, and all of that. So, this year we had quite a selection of interns. We usually only have about 4 to 6. We decided to up the game, and we had 17 or 18 interns this semester. So it was a lot of fun. It was different for us. We've learned a lot. We've learned things we do different, do better. And this is our list of interns right now. So I want to thank all of y'all, and I am going to turn it over to Ms. Velasquez.
Hello, my name is Dawn Velasquez. I'm going to be talking a little bit about, we have 3 different types of internships this year. We had something called the lead interns, and we also had rookie interns. And our rookie interns consisted of STEM interns as well as robotics interns, which was different this year. So I was in charge of kind of overseeing both internships along with overseeing the lead interns. And my internship actually started a week and a half prior to the actual internship that everyone else started. And when I was doing that, I started off with brainstorming ideas of what is our STEM internship going to consist of? This was the first year we had done a STEM internship, and how can we make an internship just like our robotics internships that's at a collegiate level, and what will this internship consist of? Having every week have a science week, a tech week, an engineering week, as well as a math week. And how will we put this in coordination and make it go smoothly and everything? So in doing this, I also have to think about how are we going to have our STEM internship fall in line with the camps that we do during the summer. So every year we do camps. This year we did a purely STEM camp along with the robotics camp. So whenever we were planning these, we had to think about, well, what equipment do we have? What do we want the kids to learn? And how can we make this a collegiate level experience for our interns? Also, other things I did was I learned how to kind of operate and how to fix some machines that were pretty expensive. And for me, that was really scary because I don't want to mess up like a really expensive machine. So I had to do research on how to operate, not how to operate, but how to fix it without breaking it. Another thing I did is I had to learn how, since Brian said we had a lot of interns, how do I communicate what we want to 17 other people? And sometimes this went smoothly and sometimes it didn't. But you always learn how to communicate better. And I feel like I learned a lot on how to communicate with a large team and with 3 different teams at a time. So I would have to talk to our leads, like, hey, how are things going? What needs to be improved? Are they doing kind of what we envision for them to do? How can we make it better? And then I would talk to some of the rookie interns, like, hey, how are things going? What do you need help with? And in doing this, I learned how to be a better mentor. In the past, I've done a lot of the project management, and I've learned how to get better at managing projects and scheduling and how to create these plans that we want to conduct, especially like from what time to what time, what are our goals, what are our objectives, and so we had to come up with these throughout the week. And so I'm going to pass it on to Anthony Zambrano, who was another lead, and he was in charge of the STEM rookies. So he's going to tell you a little bit about his experience and kind of how things went like that.
Howdy, I'm Anthony Zambrano. I go to Texas A&M University and pursue my electrical engineering degree. This summer I worked with Charlotte Goseca and Sarah Adnan for a brief period of time to help lead our rookie interns for STEM. Charlotte had to leave midway through the internship for career reasons, but she was a great help. She helped plan out a lot of our stuff, as well as going to meetings with Donald and the other leads to get our plan sorted out for the week and for the overall internship. For deciding the actual planning and the actual details of the STEM internship, I was posed with several other tasks as were the other leads. We had to make a website as well as fix a couple of devices in our lab. The website was for the FTC international teams who would come from like China, India, and all those external countries. When they would come here, they would have to bring their supplies, and it was a big hassle for them. So Sanjay volunteered to make this website that will be allow them to schedule meetings with the teams already located here in the Houston area. So if they need supplies, if they need materials, they can easily schedule that up and set up a meeting. And for that website, I had a research into LSAMP, and that is an Apache server that worked with the MariaDB database and interpreted PHP languages. So I had to look into HTML as well as CSS and a lot of JavaScript. I wasn't able to completely finish it this summer. I'm still working on it. So far, I've got the private server on our local computers. So it was really fun to, look into that and research that area, something I haven't done before. And I was able to expand my knowledge regarding those programming languages. Additionally, we've been working on this BB-8. It's about this big, and it's a big robot, and we had to take it apart because it wasn't working recently. So me and Brandon, another lead intern, we had to take it apart. We redid some soldering. We found out some issues with its circuit design where it had a capacitor missing. So it was just stuff I had to look into and research and expand my knowledge, which I found very useful as an aspiring electrical engineer. I got to work on these hands-on activities, as well as do my project management with the STEM rookies, and as well as helping out the robotic rookies every now and then. While it wasn't perfect, we had our issues in scheduling this stuff and trying to keep it at a collegiate level. We did make sure that we had at least the necessary equipment for our rookies to use, who were then able to create a very successful camp for our kids, which were around 18 or 17. Kids had a lot of fun. It was a very, very successful camp. A lot of things were learned in the STEM related fields. Thank you once again. Brandon, Rodriguez, and Bruno will be speaking to us now about the robotics.
Hello, everybody. My name is Bruno. This summer, I got to take part in this internship as a lead, and alongside Brandon, Anthony, Charlotte, and Dalin. And a little bit about myself. I just recently transferred to the University of Houston to work on a mechanical engineering degree, and I will be starting classes this fall. So I'm very excited about that. In terms of the internship, I definitely learned a lot this summer. I got to work on some of the more technical side of the internship when it came to working on things like 3D printers or CNC machining, as you can see on board there. I also got to work with Lego Studio, which was used to not only design a robot arm out of milestones, but also to create an instruction manual. And I really had to pay attention to detail there because I had to make sure steps were in chronological order. I had to make sure the perspective, the angle, everything was readable. So I definitely had a lot of learning experience doing that. I also learned a lot of important leadership skills. I learned to communicate and listen to our other rookie interns and share ideas between other leads and them. What else did I learn? I also learned a lot about, I definitely was brought out of my comfort zone when it came to sharing ideas with, like I said, with the rookie interns and also with when it came to group settings, discussing ideas for camp and things as such. I don't really have much else to say. I just like to thank Brian and Sledge for giving me the opportunity to come back this year as a lead, and I will be passing it on to Brian.
Again, my name is Brian Rodriguez. I am going to UHCL for computer engineering, and this internship was definitely interesting. I was on the other side of the interns. I was a lead intern this year instead of a rookie intern, so it was definitely a lot different. We had to do a lot more project management and a lot of other different projects Sledge gave us. So Sledge would come in and give us some random project, and we had to do that. And we had to drop everything we were doing and do something else. And it was definitely a lot interesting compared to last year. We definitely had to do a lot more communication with other leads and more planning of how their STEM or the robotics internship kind of went. So I know this internship is a lot more focused on research. So we definitely had to research a lot more stuff to do with their internship. I know we had a AI kind of section in our internship, so we had to do a lot more research on that, like how AI works, how you can do projects for AI, or how GitHub works, or how just coding in general is more operated. So we definitely have to do a lot more research on that, and then how to plan and communicate with 6 other interns while a STEM internship is going on. So it's definitely a lot more interesting this year compared to last year, where I was just the intern doing the other stuff. And we definitely have more projects. I had to fix definitely a couple of 3D printers. A part broke in the 3D printer, and we had to actually 3D print a part for that ender. I also helped fix one of our expensive quality printers because it wasn't working. And overall, it was kind of a little mechanic for that. And I would like to thank Brian stuff for running that. I did not think I really about that, but I'm glad to be able to happen this summer. Also, all the leads or the other interns think of being so kind.
And that's all. It's a staff group now.
Yeah, I think this is
My name is Ivan Pellegrino, and I was a STEM intern this year. I currently attend San Jac Central Campus for my natural science degree, and then I plan on transferring to the University of Texas to be a dental hygienist. What I took from this internship, I learned many things, from physics to coding to even being in a new environment around the camp. It was very fun and very exciting. And I thank Sledge and Brian for letting me be a part of this fantastic experience. Thank you for everything.
My name is Jesus Baltasar. I go
to Sanjay right now for the summer. I'm planning to get a bachelor's degree in computer science. In the fall, I'm hoping to transfer to the University of Houston main campus. Well, I've really enjoyed this so far, and I'm thankful to be given the opportunity to work.
Hello, I'm Jason Sanchez. I attend Texas A&M University, where I'm studying chemical engineering, class 2026. Overall, this internship was really great. I learned a lot of new things, met a lot of cool and smart people, and overall just expanded my knowledge. And like I said, I'm very grateful to Brian and Sledge that they gave this opportunity and everything.
Hi everyone, my name is Patricia Morenas and I currently attend here at San Jack. I'm currently getting my mathematics associates and then I plan on transferring to U of H Clear Lake. I just want to thank Sledge and everybody a part of the internship. It was a really great experience and it was so nice to teach the younger generation and hopefully inspire them to keep on going in a STEM major.
Hi, my name is Kennedy Brown. I currently attend the University of Texas at San Antonio. I'm a biology major with a pre-medical concentration, and I would just like to thank Brian and Sledge for this amazing opportunity and the whole LSAMP team. I learned a lot during this internship, and have many valuable experiences that I can take into the workplace. I think something I learned that I can bring with me in the future is coding. I never got exposed to code before, so I'm just very thankful that I can bring that with me.
And now we will start our presentation report on the internship. So what we've learned from, I'm currently doing Science Week, and what I learned from Science Week was renewable energy, gyroscopes, chemical reactions, and force. So renewable energy, what I learned from renewable energy from the United States Energy Information Administration was that the two most commonly used renewable energy are wind and biofuel, which is very interesting. I didn't know that before. And one of the cons of renewable energy that I didn't know was that renewable energy can be very expensive. The installation for solar panels can cost up to $11,560, which not many people like I can afford. And so chemical reactions, I learned from neutralization reactions that occurs when people do not have acid and base reaction from one to each other, which is really interesting review. And from force, we learned force from roller coasters because we had a little roller coaster with camp. So force played a role in learning about roller coasters because without force, if the roller coaster cart will eventually stop, and unbalanced force can cause the roller coaster to change movement. So that's really important whenever it comes to roller coasters. I learned about gyroscopes, which is something I've never learned before. And, statics and dynamics. I never really took a physics class before, so this was something really interesting to learn. I learned that dynamics has a branch in movement and statics is just completely stopped. So it was really interesting. Dynamics also plays a role in roller coasters because without dynamics, the roller coaster will become unbalanced and unstable and everything will fall down completely. And statics helps everything be equal. So that means the roller coaster will be able to stay stable as well. And then for gyroscopes, I learned that it was first developed in 1852 to represent the Earth moving on its own axis. And so a gyroscope has its own axis and able to spin. So that was really interesting for the kids to learn. They really liked the gyroscopes as an activity because they were able to see how the Earth moves as well as playing with the gyroscopes. So it was really fun for them to learn. And then, so we did some science experiments as well, such as oobleck, rubber balls, building bouncy balls, and even doing elephant toothpaste. Elephant toothpaste was something I've never heard about before. So it was really interesting doing a research paper on it, especially like whenever I saw the elephant toothpaste shoot up, I thought that was really fun and really cool. Oobleck, I've also never heard of. It was really fun seeing though, like creating it as well. And I didn't know that you can make a bouncy ball until this internship. I thought it was all just process manufacturing, stuff like that. And so for elephant toothpaste, it is an experiment that produces a foaming substance caused by the decomposition of hydrogen peroxide. And using Houston water as a catalyst. I thought it was very interesting to see that the higher the concentration used for hydrogen peroxide was the higher it would shoot up. So I thought that was cool. And then for bouncy balls, it was an experience that we showed to the kids that expresses the reaction between borax and glue. When they're combined, it produces a flexible polymer that changes the borax polymers and makes it more bouncy. And then for oobleck was very interesting to me because I saw that no matter how hard you hit it, its substance changes from a solid to liquid, which I thought was very interesting. It is an experiment that causes the suspension of cornstarch and water that can behave like a solid or liquid. And my thoughts on Science Week was that Science Week was something I was more experienced in because since my major is natural science, it was a nice thing to review. It was a nice week it was a nice first week to get started for the internship. And I felt confident at the time. I felt like I was going to be an expert at this. And then it was very fun and exciting to learn about the new experience I've never learned before. And I even learned a bit of physics, which I've never learned, that I never took a class about either. So thank you for the opportunity. And I'll pass it on along to this.
All right, I'm going to be talking about Technology Week for the internship. So for Technology Week, we had to research a few things, including AR, VR, augmented reality, virtual reality, and artificial intelligence and how these machines can learn. So even though we didn't really use AR or VR in the camps, it was interesting for me personally because I want to be a technologist. I want to major computer science. So it was interesting to see how augmented reality technologies had developed over the last few years because I learned that Google Maps was trying to do augmented reality with it, and it was pretty cool. I just thought it was cool. Okay. So for actual things we did for the week, we did a few things. We had Scratch, GitHub, Positbots, and machine learning, which you'll see with that. I'm going to go into each of them. So for Scratch, it was a website that we used, and we had to learn block coding to make our own little games. Up here is a picture of Patty's game, which is you play the shark, and you read the diver thing, and you get points. We had to block coding, and I really enjoyed this activity because I personally want to go into game development, if I get my degree. So I really enjoyed Scratch, coding games. The next task we did was GitHub, which if you don't know is, it's a repository site, which means people can upload their code there and other people can download the code and work on it. So we used GitHub, and we had to take a file and change the code and then upload it to our own repository, which I really enjoy too, because if you go into any career in computer science, you're going to want to know how to use GitHub because pretty much everybody uses it in that field. And here's our repository with all the files that we worked on. Okay. The third thing we did was we worked with Autobots, which are these little robots that, the way they work is you draw something with black marker and then they follow the black marker, but you can use colored markers and they'll read the sequence over here. They'll read these sequences of other colored markers and they'll react how they're supposed to, which was pretty cool. And I like this activity because it showed me about line coding, which I didn't know before. I didn't know this thing to do. Those are pretty fun to make like a little, like, that symbol. Okay, for the fourth thing we did, it's like machine learning, which was, we went to this website and we set up we set up a machine that would like, it could sort an image into two, three, whatever many groups, but what was supposed to do? And it could sort an image like on two groups based on like other images you would feed it. And here's an example. So like the AI can know that this is like mostly a horse. And I really liked that activity too, because it showed me just how AI can learn, because before this, I had no idea how AIs or machines learn. So yeah, so I'm done with this week, and I'm gonna pass on to Jason Sanchez to the engineering week.
So to start with engineering week, we were obviously given research topics, and one of the main things research topics was about circuits. And me personally, I've never messed with circuits or done any sort of circuitry before, so this was a very interesting topic to me and very opened my knowledge over circuitry and everything. But yeah, we learned what makes a circuit, the components of a different circuit, as well as microcontrollers and many other things. So we were tasked with 3 different things this week. The first one was robot rumble, which was to organize and overall better understand them. Arduino, which was to complete all the labs in a little booklet. And Milestones was to create a bot and perform different sort of tasks that we were given. So I'm gonna go over robot rumble. So what robot rumble, So first thing we were tasked to do was obviously organize these cases because they weren't organized, and that was pretty easy. Then after that, we were to better understand them, know how to build them, how to make them, and control them, so to possibly use for camp. Sadly, we didn't use it for camp, but hopefully they will use it in the future. But overall, this was a very little fun activity to make little small bots, and yeah, overall very fun thing. The next thing we did was Arduino, which was this little basic booklet which had over 18 different tutorials and labs, and we were tasked to not only complete those, but write a little report about it, but that consisted of the materials, process, as well as our overall thoughts. And this, in my opinion, was very fun because I've never messed with anything circuit-wise, so I was able to learn how to complete a circuit, the parts like resistors, capacitors, sensors, speakers, as well as LEDs. So overall, this was a very fun activity, and I hope to possibly use this in my future career and whatever I do. And one of the last things we did was, of course, the Lego Mindstorms. Now, me personally, I have messed with the Lego Mindstorms before in my elementary and junior high days. So this is a very fun this is very fun for me to come back to. So yeah, we were tasked to build a bot to perform different tasks that were given us by the leads. And as you see right here, these are examples of some of the bots we made. They were all very unique and very fun. And overall, it's a fun thing. And we were tasked to not to do it, but also code them using the same block code as we did with Scratch. So we were all very good with it, and we all finished the task very easily. And it's overall a very fun project to do. So my overall thoughts of this week was, this week was a great week because I not only learned new skills, but I also was able to refresh some old skills as well. And hopefully I get to use this stuff in the future with my careers and everything else. Now I'm going to pass it on to Patty.
Okay, so my main focus over the internship was I did the math week. So we had 3 main categories that we did. We went into logic, and we did the Tower of Hanoi and the Mobius strip. We went into art, we learned about symmetry and angles and tessellations, and we also went into angles a little bit in a different way, and we did that using putt-putt. So first I'm going to talk about the Tower of Hanoi, and when I came here, I never heard about this, never seen it, nothing. But it's a mathematical game or a puzzle that consists of 3 rods and 7 different discs, and there's 3 rules to playing this game. You have to make sure that everything on the left side of the puzzle is the exact same order on the right side. But to do that, a large disc can be on top of a small disc, and then each little disc has to be on a rod, except the one that you're moving. So when we did this, there's a mathematical formula behind it. I learned it was an exponential formula, and the formula is 2 to the power of x minus 1, and x in this case is the number of discs that you're on. So if I only use 3 of the discs, that means it will only take 7 moves for me to get all 3 discs to the very right side. And if I use 4 discs, it would be 15 moves. We also learned about a Mobius strip. I also didn't know what this was, but I taught it in the camp to the kids, and it's actually really cool. It's a loop surface with one side and one edge, and that basically means if you start on one side of the strip and you just make a continuous line, you will eventually end up at the exact same spot that you started at. So you can actually create a Mobius strip using 2 ends of a paper. You keep one straight, and then you flip the other side 180 degrees, and then you take them together. So we did this, but we also learned what would happen if we cut in the middle along the entire strip, and you end up making a loop, and then we cut again on that loop, and you end up making 2 conjoined Mobius strips. So we did that demonstration in camp. It was really cool, really fun. And we also learned about math and art. There's a lot of different things in art. Artists use a ton of math things. They use geometric structures, proportions, patterns, and linear perspective. So first, we'll talk about symmetry. Symmetry is an illusion that one half of the image looks just like the other, but it's just mirrored, it's reflected. And the line in the middle is known as the line of symmetry. It's that imaginary line where like humans can distinctively see that there is that line where it is reflected. And we also talked about angles, and I didn't know, but in art, angles, they cause subtle mood changes for the viewer seeing them. So lower angles make the viewer feel like they have power, and then higher angles made the viewer feel like they're a little anxious and overwhelmed. And then we also practiced using the protractor. It was really cool. And then we also learned about tessellations. Again, I never heard of tessellations, but we created our own tessellations, and then we let the kids in the camp create their tessellations. So a tessellation is used to create, it's repeating patterns all together, and it looks like the image can go on forever and ever and ever, and it will never end. The image never overlaps with each other. There's never like any space or breaks. It just is a continuous long thing. It's really cool. And then lastly, our main project, like our main thing we did was angles, and we did it using putt-putt. So what we learned was once you hit the ball at the wall, at a certain wall, it will exit that wall at the exact same angle that you hit it at. So that basically means that when you hit the ball at the wall, it is reflected, of course, on the same angle. So when you hit a ball with the wall, it's not just going to stop. If you hit it with enough force, it's going to want to keep on going, but it just goes in the same angle that you hit it at. So we learned that, and then if you hit with enough strength, you're able to actually hit multiple walls. It's possible to hit multiple walls, and then you could bank and then hit a hole in one. So we did that with the kids. We made our own putt-putt courses. We used these big old Lego blocks, and yeah, we made sure to include angles in them and everything. So my thoughts on Math Week, it was really great. Whenever we first introduced it, all the kids were like, oh, Math Week, like they just didn't want to do it. But then at the end of the day, they all were happy, everyone changed their mind, they had a really great time. They didn't even know they were doing math without doing it. They just had a really great time. So that's it for Math Week, and now I'm going to pass it on to Kennedy.
Hi, I'm back. So not much for me. I talked about project management, and this was done throughout the course of the internship, but we focused more on it week 6, which was right before camp. Basically, we took the activities that all my fellow interns just discussed with you and compiled them into a schedule. This was done by making a proto schedule, the prototype schedule, meeting with our fellow leads and project managers, and compiling them into a schedule like this. This is a sample from Monday's schedule that we used during camp. Once that was done, the rookies were tasked with how to execute the schedule during camp week. We tried following the previous schedule as closely as possible, but of course, life happens, and we had to figure out how to proceed if activities went over time, if they weren't going as well. And so we used our problem solving skills and experience with the activity to decide how to proceed. My thoughts on the project management aspect of camp, I thought that the rookies and leads did a really good job of compiling a schedule, especially in an 8-hour day when there's so many different topics in STEM. And I'm just very proud of what we put out, and I'm so proud of the campers. And that concludes our presentation. Once again, I speak on behalf of the rookies and leads. We're very thankful for Brian Sledge to give us this opportunity to complete this internship and to hold this camp. And we have lifelong experiences that we can bring to the future. Thank you. So, we will now be starting the robotics presentation.
Okay. My name is Isaac Villarreal. I am a student here at San Bernardino College. I'm currently a mathematics major, and I am hoping to transfer to U of H, Houston, and get my bachelor's in computer science. One key takeaway that I got from this internship was connecting programs to electronics, and we'll see that later in the presentation. So this is our internship recap, and we're going to begin with week 2, which was circuits and electronics. And we basically started off the week learning about microcontrollers and different electrical components that are used to build little systems to power an LED or take some sound and record it, power a motor in a small scale. It later came helpful when we started building the Tetrix robots. And then we went to Wednesday and Thursday. Wednesday and Thursday we started working on the Raspberry Pi, which is basically a microcomputer and a microcontroller at the same time. It is programmable, and when we received it, some of them had some operating system already installed, and it made things complicated, so most of us decided to erase what was already on it and start from scratch. And it's a lot of fun. I'm going to hand it off to Michael. I'll be back for another slide. Thank you.
Hello, I'm Jose Rosas. I'm currently attending the University of Houston in Clear Lake and going for my mechanical engineering degree. One of the major things I took away from this internship was better development of my teamwork skills, as well as my critical thinking and time management. And I will be talking about week 3, programming. Our week started off with us learning about various different programming languages. So we're starting off with Scratch, which talks about block coding, how to input code onto the sprite and make it just 3 different commands with a simple block code. And then from there, we went into Autobots, which talks about line coding, which went into more robotic-esque coding, as it did the little line code to make the Autobot move. And after that, we got into the more complicated part, which was the Java coding, which is what we use to build off of for the rest of the week, leading us to next week. We learned about Java, how to program different motors and everything. We had some couple problems, so give us more of a basic understanding, starting off with mathematics, and then going on to building our own type of digital machines, such as a vending machine. And then from all those little tasks, it helped us develop from a basic understanding of Java to a more complex understanding to help us on the following weeks for our robot building. So I'll pass it on to Michael, who will be in charge of building this robot.
Alright, so my name is Mike Cortez, and I am a mechanical engineer. And something that is like the key takeaway from this internship is that I really like the coding aspect and the mechanical building of this internship. Because right now I'm still taking sophomore level coursework, but that's going to really help me out for junior level coursework that I'm going to be taking next year. So for this week, we built the mechanical Tetris robots. For those, we were tasked with building a chassis and what had 4 motors for separate wheels, and then we needed a robotic arm and a robotic claw as well. So some of the challenges that we experienced during this building process was like the mechanical building aspect of it, where whenever we were building it, we needed to find out sometimes where we were working with gear ratios whenever we would do the wheels. Because one team used the gears so they could turn the wheels, and then other teams just connected the motors straight to the wheel axles. So we had to do a little bit of math to figure out how to control the gears, because some are bigger and smaller, you get different ratios of power between them. And then also, we use that for the arm as well, either a motor or a gear. And then also, we had the same system set up for the claw as well, whether the motor or the gear as well. And then, something that I really liked about this one is the troubleshooting aspect, because you would see a problem arise that would need fixing, that you would have to fix it either to the code, or you would need to go back and look at your design and see what else you need to change on there. And so something that I noticed from another group is that it was a little bit harder to use the gear ratios, because it was just a little bit more math involved. So we decided to just connect the axles straight up to the actual wheels. And so the key takeaways from this that I learned is that we incorporated circuitry. So from the past week, we incorporated that, and also programming from the week right before this that helped us learn how to control the robots. And then you'll see on the next slide for the next week, I'm going to hand it off to the next person.
So I'm back, and Monday, Tuesday, and Wednesday, we worked on making that robot that we built, teleoperated or teleop, and that basically means controlled by a human. One group, which was my group, we had a little bit of trouble with the lead interns provided us with code, but their robot only had 2 motors and the drive base. Mine had 4, so we had to figure out how to adapt and create the code for that. And then we ran into an additional problem is each one of the control hubs only has 4 ports for 4 DC motors, so we had to add an extension hub to it. That's why that robot has 2 boxes to each side of it. That was quite different because I didn't know how to do that. Some of the lead interns just referenced some of the documentation, so I had to go find the information I needed to plug that in. And then Wednesday, there's a mistake. Okay, sorry. Wednesday through Friday, we worked on the autonomous part. For the robot to be autonomous, it had to be a lot more precise, so we had to go back in and change our claws. I think all 3 groups went back in and changed their claws so we could grab the apple more efficiently. It wasn't a really big problem when we were controlling the robot with the remote control, but because now the code was working by itself to pick up an apple and place it where you assigned it to go, you need the precision. The motors had to be powered down a little bit because it was quite hectic. I broke several motors by accident. I'm sorry. If you get the pieces, I'll fix them. And that's it. And we'll lead it off to our coworker, Amber.
Okay, hi everyone. My name is Amber Benavidez. I attend Texas Tech University, and today I will be talking about
The right one, the right one, the right there.
And today I'm going to be talking about the project management aspect of this internship. So project management requires everyone to be a little bit more social and communicative with each other than before. Before we were, kind of working in groups, working in pairs, working on our own. But then when project management started, that's when we had to get the input of not only the leads, but also Sledge and our fellow rookie interns to decide how we wanted to schedule things and what activities we need to switch around and etc. So a little bit of what we did for the actual preparation is that we gathered all of the activities that we had done research on before in the previous weeks, and we scheduled those into the camp so that we could implement those with the kids. We worked on assembling the kits for all the different activities that they were going to do. We had to reorganize the downstairs room for all of our campers so it looked nice and it looked welcoming for them to have a good time. We did have to charge all of our different little robots that we were going to let the kids use. And we did a lot of scheduling during this week, and we had a couple meetings, with the leads, and we had a couple scheduling conflicts, but it worked itself out in the end. And I think that even though we didn't follow our schedule, word for word, it was a really great outline for us to follow, and it was a really good thing to look at that was consistent for us during camp. A couple of other things that we did is we made personalized folders, name tags, goodie bags for the campers that were going to arrive. The contents of the goodie bags had stuff, all of these different things that had to do with our camp, so little robots, agriculture-themed activities, and Legos and stuff like that. And so overall, I think that our project management week really helped with communication. I think it really showed both the leads and the rookies that we needed to communicate a little bit better, but I think that it really prepared us for our upcoming camp. So I'm going to pass it off to Sophia, and she's going to be talking to us about Camp Week.
All right, hi guys, my name is Sophia Eula. I attend Texas Tech University and I'm an animal science major. I'm going to talk about week 7 of our internship. That was the big lead up. That was our camp week. So throughout camp, we did activities like understanding what robots are, how they work, what sensors are, some educational stuff like that. And then we also let them do mechanical building, like they built the Lego Mindstorm arms that Bruno had talked about earlier, creating PDF for and stuff like that. And then we also had them create some solar robots. They played with our Tetris robots that we had built. And then at the very end of camp, they also built a Lego robot that they took. Throughout this week, we really tried to focus on, not only time management, but what the kids were interested in. If the activity was going well, then maybe we spend a little bit more time on that activity. If they were not really into it, maybe we switch the activity a little bit. Overall, I think the week went really good. The kids seemed to love camp. All the activities that we planned, they really enjoyed it. Got a lot of positive feedback from parents at the end of camp saying, oh, my kid was so excited to go to work or, to go to this camp every day. We'll definitely be back. So that was, great to hear. Here are some images. This is just throughout camp of the kids. And then, of course, because our 2023 camp, it was agriculture robot themed. So with that, during camp, we had to, implement activities and stuff and tasks for them to do that, kind of incorporated agriculture. So one of the activities that we had on the very last day, we had a robot rodeo. Here's some images from that. We had activities, we named them different things based on, rodeo experiences that you might have, like barrel racing, a horse race, bingo, the little, carnival games, stuff like that, just to make it fun, with still making it educational and about robots and, still keeping it like it's a robot camp, But I think I can speak for our entire robot team in saying that, we're very grateful to Sledge and Brian for this experience. We're very happy with how the camp turned out. And I think overall it just was a very successful experience. Me personally, I think as an, I'm an agriculture student at school as an animal science major, this field was definitely a step out of my comfort zone. I think that I had to learn a lot of, maybe pre-rec things because I'm not necessarily in this field. But I think that we had a great team of not only peers and leads, but just the environment that's created here was very welcoming, and I was able to overcome those challenges and learn and, expand my knowledge about robots and everything else. So yeah, that's the end of our co-op presentation. I'll give it up to Brian.
Okay, let's give the interns all a big hand. I think y'all did a wonderful job in great 8 weeks. So thank you. Hopefully you all learned a lot. I know they were talking about the time management pieces and camp week, and we did both camps at the same time. It was a little different for us this time. So some activities would be scheduled at the same time, so they had to work at switching that up. They did a very good job of pivoting and doing what they needed to do, and overall making sure that the kids, which are the most important part of camp, had a really great time. Everything I heard from the parents and the kids was that it was a great success, so thank you. And so then I want to thank all of y'all for participating in the internship. It's been nice seeing the ones that were here last year come back and grow a little bit, seeing the new ones, and meeting some really great people. And for the ones that are going to be here at San Jack, we hope that we continue to see you and you're still part of the program. And so I want to thank everybody for coming, and that is the end of our presentation.